Alrighty, everybody, welcome to the Morrison Planetarium. Just to let you know, we're going to get started in about a minute or so. We're going to see if anybody else is going to come on in and join us for the last planetarium show here at the Morrison Planetarium. And I do want to remind folks that just a heads up, the show that we're about to watch is 30 minutes long. This is going to take us to the closing of the museum because the museum closes at 5 o'clock today. So make sure this is where you want to be for the last 30 minutes at the museum today. Although I personally think this is probably one of the best places to be. Alrighty, everybody. Just a heads up. I just got a report that we have a lost child. They're found. If you happen to have a child named Monica who's wearing a pink jacket, they are at the information desk. So if you're here in the crowd, Monica is at the information desk. Alrighty. Alrighty, everybody. Well, I just got the okay to start our planetarium show. So I'm going to switch gears. I'm going to put away our space trivia questions just because we're going to be heading into the unknown. Ooh. And once again, welcome everybody to the Morrison Planetarium. I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter for this show. And just to let you know, I'm standing right behind you up at the pilot's booth. But don't worry, don't hurt your necks. I just want to let you know that I'm right here, but the whole show is going to be up on the screen where you're about to see. So everything that in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout this planetarium, which is going to give us that very immersive experience. And just to let you know, folks, the show that we're going to be watching today is different from all the other ones that we've done here in the Morrison Planetarium today. This one's called Tour of the Universe. Essentially, what that means is that you're going to hear my voice for the next 30 minutes because we're going to start off pretty close to home and we're going to zoom all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis, but I just got to warn you and prepare you. And before we get started, I got to go over some quick house rules just so that we're all on the same page. You're going to have a great experience in here. First off, there's no food or drinks allowed inside. If you manage to bring any snacks, make sure those are put away to the very end of the show. We want to keep this place nice and clean. That also includes no feetsies on the seatsies because, again, we want to keep the seats nice and clean. Thank you, y'all. And the second one is the biggest one. Please wear your mask while you're inside the Morrison Planetarium. It looks like we have about 80 to 100 people in this planetarium dome right now. So again, we want to make sure that everyone's safe. So please wear your mask over your nose during the entirety of the show. Thank you so much, y'all. And also, if you happen to have any electronic devices like smartphones, smartwatches, laptops, beepers, if you still got them, now's the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, because having a really bright white light in a very dark room like this planetarium could be distracting for the folks sitting behind you. So thank you again, folks. And folks, if you need to leave for any reason during the show, please make your way up the stairs. That's where the exits are going to be located once the show is over. And also, this show is very immersive. If at any moment the show becomes too overwhelming, you become motion sensitive, all you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But otherwise, that's all I have to say. Are y'all ready for a planetarium show? Alrighty, folks. Sit back, relax, and stare into the dome before you. Alrighty, folks. So again, I said that we're starting off pretty close from home, but this place doesn't really look like home because what we're looking at is known as the International Space Station. We also like to call this the ISS for short. But if you do notice, right down below there's a large sphere. That's our home. That's planet Earth just down below. So the International Space Station is in a low orbit just above Earth, not too far away, only 225 miles above the surface of the Earth. So 225 miles, that's like a nice little road trip from San Francisco to Santa Barbara, a nice getaway with the family for the weekend. And it looks like we're just above dusk right now, which is why our Earth looks a little odd. It's just because it's at that line between nighttime and daytime. So it looks like we're heading into the daytime just slightly. And folks, the International Space Station is a wonderful, amazing place. Essentially, this is a collaboration between many nations across planet Earth to pretty much figure out what happens to things in space. So they conduct all sorts of science experiments up here. Pretty much, they just want to figure out what happens to things in space in a low gravitational environment. For example, how does a plant grow out in space? How does fire work out here? And what are some of the properties, or how does water behave out here? So these are all the different types of things that they conduct here at the International Space Station. And this thing is going incredibly fast, folks. It's going a whopping 17,000 miles per hour, where it orbits once every 90 minutes, where the International Space Station experiences 16 sunrises and 16 sunsets a day. Whew, that's romantic. And folks, this thing looks incredibly enormous here on our screen, but the International Space Station isn't too big. It's only about the size of a football field, but it keeps getting bigger every year because they keep adding new compartments, new modules to it, so it gets bigger every year. And folks, for the most part right now, the International Space Station is as far as we put humans into space nowadays, because traveling into space gets quite expensive. First, you got to get yourself a rocket, then you got to get yourself rocket fuel, and you need rocket fuel for that rocket fuel to get more rocket fuel, because you need more rocket fuel for that rocket fuel. And then eventually you'll be able to launch out into space. But not only that, you have to bring food, water, and not to mention all the air you're going to be breathing while you're in space. So the bill gets quite costly quite rapidly. But for now, we're going to leave the International Space Station because we still have a long ways to go to the very edge of the known universe. We're going to see it slowly disappear compared to our planet. But it's going to stay on screen with our nice orange trajectory line that we have. And as we start to zoom out, folks, you're going to start to notice our planet Earth, one of my favorite places in the entire universe. You notice looking at the Earth, it's filled with an assortment of colors, from the whites of the clouds that show evidence of moisture. We also have the oceans, tons of water here on planet Earth. And then as we start to fly around, you're going to start to see all the browns and greens from the land masses and vegetation here on Earth. But we're going to leave Earth for the meantime, because we're going to be heading on over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before. This was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. And folks, this was the only brief presence of humans on another body in our solar system. And it looks like we are getting a new moon, which means we're not able to see the moon, but thanks to this awesome space program that we have, I can do some really cool things. I can turn the nighttime off here on the moon so we can get a better view of it. Now again, folks, 1972 was the last time we had humans on the moon. That was more than 50 years ago or so. But don't worry, NASA has a new mission in the works. In the next year or two, Artemis will be launching out from Earth and be making its way to the moon. So just look out for NASA's Artemis mission. Pretty much what they're going to be doing, they're going to be sending the first woman to the moon. But not only that, they're also going to be making great strides to start setting up a lunar base here on the moon. Essentially, we humans want to travel out and explore our solar system. Our main target right now is Mars. But before we send a whole heap of folks out into Mars, we've got to pretty much figure out how we're going to be living out here on a celestial body. So instead of taking a 6 to 8 month trip all the way to Mars and trying to figure it out there, the moon is a much easier stepping stone to figure out how we're going to live out here in space. So keep your eyes peeled for any news about Artemis. Should be coming out in the next year or two. And folks, here on Earth, when we look up at the moon at nighttime, it almost feels like you can reach out your arms and touch the moon. But the moon is incredibly far away from us. It's about 240,000 miles away from the Earth. 240,000 miles. Some of you folks may own a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop at 80 miles per hour. Although I cannot recommend it, the roads are poorly maintained out here. And folks, we're going to now need a better measuring stick, because using miles at this scale is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But for now, we're going to leave our moon behind. So everybody say, bye-bye, moon. We'll see you later. And now, folks, we're going to be taking another leap on a much greater realm of our solar system. We're going to watch the moon and the Earth and its orbits as they slowly recede. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate images and information available to us. And now we can see the nearest star to us, the sun, come into view. The sun is about 93 million miles away from the Earth. 93 million miles away, that seems really, really far away. But in terms of light speed, that's only 1.5 minutes at the speed of light. So again, we have the Earth right over here, and Earth right here, sun's right over here, so 8 minutes at the speed of light. Now that's a fascinating concept, because if the sun was to turn off all of a sudden, we humans wouldn't know about it here on Earth for about 8.5 minutes, because that light, the last bit of light that emitted from the sun, takes time to travel that very long distance. So for 8.5 minutes, we wouldn't know about it, and then all of a sudden, it would be nighttime here on Earth. Pretty cool concept to keep in mind, y'all. And since we have a nice bird's eye view of our solar system, I'm going to name all the planets real quick. So right in the middle, we have our sun, Sol. And the closest planet to the sun, we have Mercury, Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places where you can land a spacecraft on, although I wouldn't recommend it for some of them, because some of them have some extreme temperatures. And then beyond Mars, it looks like we have an empty gap, but this is actually where our asteroid belt would be. And this is what the asteroid belt would look like if it were to highlight all those asteroids. There they are. So this is the asteroid belt, folks, represented by our nice little green dots. And beyond the asteroid belt, we have the really big planets. We have the gas giants. We have the Jovians. We have Jupiter, Saturn, Uranus, the funny one, and Neptune. And folks, this may feel like this is it to our solar system, but there's also so much more. For example, we can add Pluto here. Pluto is still part of our solar system, but no longer considered a planet, now considered a dwarf planet as of 2006. And you're probably wondering to yourself, why did Pluto get kicked out of the Planet Club? I learned about Pluto in school. Well, you see, folks, we humans got really good about learning about our solar system, specifically the outer part of our solar system. More specifically, the region beyond Neptune. And out here, we call this the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's all this stuff. Whoa, that's a whole lot of stuff. So again, this is the Kuiper Belt. This is essentially a second asteroid belt. We have mostly icy asteroids out here and icy comets. But in 2006, we found more than 400 objects, and some of them were bigger than Pluto. So we couldn't call all this stuff planets. There was just way too many of it. So all the astronomers in 2006 came together, had a great big meeting, had to figure out what exactly you need to be to consider it a planet. So they had to redefine the list or the criteria. And one of the criteria to be considered a planet is that you need to be so big and so massive that you push all the other stuff out of your orbital path. Unfortunately for Pluto, it isn't the biggest thing in its orbital path, and it also kind of dances with its own moon. So this is one of the reasons why Pluto got kicked out of the Planet Club, but now considered a dwarf planet. But don't worry, folks, Pluto's not the only dwarf planet out here in the Kuiper Belt region. We have Makemake and Haumea, just to name a couple, and we also have Ceres in the Asteroid Belt. So it's kind of like, hey, you kicked me out of the Planet Club. I'm going to start my own club, the Dwarf Planets. But I'm going to put away the Kuiper Belt for now, because that's just a whole lot to look at. And I want to be bringing up some Space Voyagers that we sent out in the 1970s to explore our solar system. There they are. So these are all the trajectory paths of these Space Voyagers. We have Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them, New Horizons, which did a quick flyby of Pluto and got us some really high definition images of Pluto. And pretty much just did a flyby and continued its way out of our solar system. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. Now, in order for light to reach all the way to the orbit of Pluto, which is, again, Pluto, this little faint blue line, it takes about 10 hours at the speed of light to get this far. So nowhere near a day. But we're going to be leaving our planetary scale behind, folks, because now we're going to be heading into interstellar space, the space between the stars. And out here, folks, our star becomes one of many out here in interstellar space. And if my calculations are right, the nearest star system to us is going to be the Alpha Centauri system, which is this one right here on the very top left. Now, to get to the Alpha Centauri system, the next star system over, it's about 4 years at the speed of light. So 4 years at the speed of light, that's about the same amount of time for a college education, at least before the budget cuts. And folks, we're going to stop to consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside the radiosphere. Now, the radiosphere represents the current limits of the most distant radio signals humanity has broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the 1930s with strong radio waves, early television, and radar signal, and then later the detonation of atomic weapons. Now, all these things are emitting electromagnetic radiation, which is strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, I'm going to be bringing up these markers. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets in our nearby vicinity. That number is going to be constantly growing over the next few years, because we have space telescopes that are constantly scanning the night sky, looking for as many exoplanets as they can. And the more that we look, we are finding exoplanets in every direction that we point our telescopes at. But do any of these harbor Earth-like conditions? Well, our technology is not yet able to answer that question. Not quite yet, but new generations of astronomical instruments are devoted for that search. But the important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, If there is anybody out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. For example, if you wanted, say, we live in one star system, and the very edge of our radiosphere on the left-hand side, let's say we are over here, we find an alien civilization on the other side of our radiosphere. We shoot them a text message, takes 90 years to get to them. They listen in, answer back, they say hi, another 90 years. That is a 180-year conversation in the making. Whew, and I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I want to put away those exoplanet markers. But I want to leave our radiosphere up here on screen because this is going to be a great reference point. As huge as our influence is in our nearby universe, our radiosphere, our electromagnetic footprint, it is nowhere near as big as our galaxy. So keep your eye on that radiosphere. Let's see if you can still see it once we're looking down at our Milky Way galaxy. And can anybody see their house from here? Just kidding. But now, folks, we're looking down at our Milky Way galaxy. And if you wanted to cross the Milky Way galaxy from one side to the other, well, this is going to take you a very long road trip because it's going to take you 130,000 years at the speed of light to cross from one side of the Milky Way to the other side. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood is any indication, in this vast star city, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I do want to stress the shape of it. When we look at our Milky Way from a sideways perspective, you notice that we live in a flat spiral disk. Now, for astronomers and scientists, when we want to learn about the universe, it's so much easier to point telescopes and equipment galactically north and galactically south instead of looking through the Milky Way, which has stars, gas particles, debris, things that obscures the cameras and the technology's path. So again, it's much easier to look galactically north and south instead of looking through the plane of the Milky Way. So just keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way is only one of many hundreds of billions of galaxies comprise the known universe. In this giant leap, we're now going to see a view where each point in light represents not a star, but rather the location of an individual galaxy, each galaxy containing billions, perhaps trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies large and small. It also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and we're heading right for it. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we start to get a better view of the galaxies near us, you're going to start to notice that galaxies are not evenly distributed through space. Instead, they clump together in great clusters or voids where there's very few galaxies. You can see a few galaxy clusters on the right. I do believe that's the Virgo cluster. And then you can also see immense empty regions where there's very few galaxies, or what looks like no galaxies in that area. And folks, now we've zoomed so far out, we're now looking at a picture that represents the 30,000 closest galaxies to us in space over 300 million light years across. Now, we've got to give a big shout out to a very amazing fellow by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation, this amazing galactic map that we're able to fly through right now. He also worked on this with dozens of other astronomers working over decades of time, and they even color coded it for us so we can get a nice view of where the galaxy clusters are. So big shout out to Dr. Brent Tolley, doing amazing work. But now, folks, we have automated systems that are mapping the most distant galaxies. So now we're going to be looking at the large-scale structure of the universe. Oh. So again, we are now looking at the large-scale structure of the universe. And just a heads up, folks, the dark areas where you simply don't see anything, these are areas that we haven't mapped out yet, so our universe doesn't really look like a bow tie or a butterfly. These dark gaps we just haven't mapped out yet. Now, remember when I just told you moments ago that we live in a flat spiral disk of our Milky Way? Well, if we were to line up our Milky Way galaxy, it would line up right here in the middle. So again, it's a lot easier for astronomers and scientists to point their equipment galactically north and galactically south instead of the plane of our Milky Way galaxy. But scientists still wanted to make sure that there was galaxies through our plane, so we have a nice little purple survey right over here. They looked at the plane of the Milky Way galaxy. They were still able to find galaxies there, but much more difficult because they had to look through a bunch of stuff. But again, our technology will eventually be able to fill in these dark gaps. It's only a matter of time. We just got to make sure our technology advances, and then we'll be able to look and map out these dark regions. But folks, it looks like we're running dangerously out of time, so we must continue pressing on. And now, folks, we're going to be looking so far back. We're now going to be looking at objects billions of light years ago. We're now going to be looking at the brilliant cores, the central nuclei of the quasars, which are these orange dots that we're seeing way out here past the large-scale structure. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press even much further beyond to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we are now approaching the very edge of the known universe, what we also call the CMB image, or the cosmic microwave background image. And here it is. Now, all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture is a very baby universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo, but a temperature density image, where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, back home. Now, before we make our return trip back to planet Earth, I've got to ask y'all to prepare yourself, because this could possibly be the worst free-falling dream ever. But are y'all ready to make our return trip? I'll take that as a yes. Let's find a nice entry point through all these quasars and galaxies. There we go. And let's make our return trip home, folks. So we're crossing an expanse of 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy. New generations of telescopes and spacecrafts are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way. We're heading straight to that radiosphere, our electromagnetic footprint. And of course, we're making our way downtown, walking fast, faces past, and we're homebound. And now we're zooming in towards our planetary system, our star system. And now we're about to pass the spacecraft that we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt, making our way to the third rock from the sun, our home, our little place where all humans have ever inhabited, the only place. And that's planet Earth, folks. And as we make our final approach to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank you all for stopping by and watching it with me today. I hope you did enjoy it. But otherwise, it looks like we made it back to planet Earth safe and sound. And that's all I have for you today, folks. Thank you so much. Have a good one.